Hello everyone. Today I'm just going to show you how you're going to get started with Hydrus 1D, which is a hydrological model that we are going to use for 202A. So first of all, you just want to Google Hydrus 1D and find the software. So you will find this is PC Progress software, and then you click this link, and then you can see there are a whole bunch of things here. Usually in this class, we will focus on using the one-dimensional software. But PC Progress does have that option for Hydrus 2D and 3D, but that will be commercial program, and then which will need a payment. So for 202A, we will just go to Hydrus 1D downloads, and then you will going to choose the right Hydrus 1D for your own computer. And Hydrus 1D can only be installed on a Windows operation system. So if you have a Mac, maybe you have to use the computers in the Davis Hall Computer Labs. As I have already downloaded Hydrus 1D, so I'm now going to download it here. And next, usually we will go to the Hydrus 1D tutorials. So this is essentially important for you to get familiarized with this software. And then there are a bunch of tutorials that is available for you. And today I'm going to show you this direct problem, infiltration into a one-dimensional soil profile, and then give you a rough idea of how Hydrus 1D works. Okay, so now I'm going to open my Hydrus 1D. So usually you will start with when you open this, it will be like this. That means that you don't really have a project now. And then first you have to create a project. So for example, I'm going to call that 202A intro. It seems that I have already had this before, so I'm going to call this 202A intro 2. You can also further add a description to this as well, like what you're actually doing. And then you click OK. And now we can see today we are going to focus on this water flow question, which is basically that we're trying to mimic the situation, simulate the situation that we have water infiltrating through the water column. Okay, so now I'm going to show you, like if you look at the GUI of Hydrus 1D, basically you have a pre-processing part, you also have a post-processing part. The reason the post-processing part is not showing anything is because we don't really have any outputs yet. So first of all, we will click the main processes, which you can change the heading to like water infiltration, for example. And then here, this is the place that we specify our processes. And then for this question, we will focus on water flow. We do have the option for solute transport if you click this, and then you can see there's a standard solute transport. Ion chemistry or HB1, which is Hydrus 1D linked with Freak C. So if you're concurrently taking soil chemistry from Civil Environment 116 soil chemistry in that class, you will be able to see Freak C. But now we're going to focus on water flow. And then click next. And then this is the geometry information where you're able to set up your style column. And we're just going to leave everything as default. And then click next. And then this is the time information, which you can specify how long is your simulation time, and then what is your time step, etc. So according to the tutorial, we will have a time of 1 day, final time 1 day, initial time I'm just going to make that a little bit smaller, and time step also slightly smaller. And maximum time step per day, probably just 1 is okay. And then you click next. And there's one thing that you may look at is the time variable boundary conditions. So for some situations, like if you have precipitation in once and you wanted to understand how rainfall infiltrates into the subsurface, then you definitely have a time variable boundary condition where you can specify here. And then you click next. In terms of the print information, so this is the place that you are going to tell Hydrus when exactly I want to have my model output. In this tutorial, we will have 12 number of print times, and then you can set it as default. And click OK and click next. And then this is the iteration criteria. So if you already taken 200A or you're concurrently taking 200B, so you may have some better understanding of the iteration criteria, how we're going to stop our simulation, for example. But we're also going to leave it as default here. And then we will come to the soil hydraulic model part. Usually, so this is essentially important because if you want to simulate water transport in a subsurface, you want to have a priori information about what this solid looks like. So here Hydrus 1D offers a single porosity model, which is a one Groupton or like a modified one Groupton, so on and so forth. And there's also dual porosity model and also hysteresis. So you're going to check the corresponding models that you want to use based on any specific questions. And then you click next. And then the next thing is that you will come to this water flow parameters, which is related with your solid hydraulic model. And then so here we can change our solid catalog, like you can change that to clay or sand or anything that you like. And then if you're not satisfied, you can just so for example, now we're at loam, and we can also just manually change those parameters by clicking that and then change that to another value. And there's a powerful neural network prediction, but I am not so familiar with that. If you want to know more, you can read the user manual. And then we will come to water flow boundary conditions. So this is a place that you can set up your upper boundary condition and lower boundary condition. And then you can have initial condition pressure heads or in water content. In this question, we will have a constant pressure head and also a free drainage boundary condition. And then you click next. And then we will run profile application and you will save the data. Okay, so now we are going to see this relatively okay GUI, then where we are able to modify some of data that we have. So first, you want to change your initial condition by clicking conditions, go to initial conditions and pressure head water content. And according to the question, we will change this top one pressure head to 1, and then leave everything else as default. And then we can add some observation point here, and then according to that, there's this 20, 40, 60, 80, and 100. And then you can see at the bottom part, there's part saying this is node, this is the elevation. So this is a place that you can see that you can find the exact location of 20 or 40 without needing to count them, And then you save this data, and then that's all for this profile information. You provide exit. Here you click exit. And now here there's a table for that. So this is also the place that you can further modify your question. So for example, you can modify your initial pressure head for all the other locations. But for this question, we don't really need to modify any other things. So we will click next. And then do you want to run your Hydrus 1D application? We click yes. Okay. And then here we can see that we do have a lot of model output, but it's slightly difficult to read them. This is why we're going to close it. And then we can see that on the post-processing part, we have a lot of things popping up. And now we can click the observation points. So this is if the observation knows what the pressure head looks like at any given time. And you can add a legend to this plot to see what exactly. So you have nodes 1, 2, 3, 4, 5. And then this is at the time what your pressure head looks like. And then this is water content, and then this is the fluxes. And also you can further see that for any given location at different time what my profile looks like under the profile information part. And then you can further see that at different time, then your profile pressure head will look like this. Okay, so this is a really fast tutorial of Hydrus 1D. And then if you do have any further questions, feel free to come to my office hours on Wednesdays. All right, thank you so much. See you soon.